Hello everyone, returning from the poultry farm to my laboratory, I'm excited to share my story. Let us start. Climate change has significantly impacted the productivity of the duck farming. There have been efforts to develop duck varieties resistant to climate change.
Recently, our poultry center has just successfully developed a duck breed capable of adapting to climate change. But the evaluation of reproductive traits is challenging and time-consuming.
Different genetic variants may influence reproductive traits. We can shorten selection breeding time by evaluating and selecting beneficial variants.
Cool. How is it done?
Now let us go back to the lab. I collected blood samples from the ducklings and brought them back to the lab for easy DNA extraction. I will explain the impact of genetic variations. The characteristics expressed by living organisms are intricately governed by genetic material, namely DNA. In nature, various factors cause living organisms to mutate, leading to different characteristics. Let us start with the prolactin gene as an example. There have been numerous studies reporting the mutation of the prolactin gene affecting egg productivity in ducks. For clarity, let us follow the example. The prolactin gene encodes the prolactin hormone. The hormone is stabilized by the molecules forming it. However, when mutations occur, the prolactin gene will produce an altered molecule, impacting the structure and function of the prolactin hormone. I've just successfully extracted DNA from the blood samples of the ducklings. There are several techniques available to detect DNA mutations, such as DNA sequencing, PCR-RFLP, or real-time PCR. Which technique should I use?
We have invested significantly in breeding program. Therefore, we need a technique that is cost-effective but can evaluate multiple genes.
Oh no, there isn't currently a technique that meets the breeder's requirements.
You should consider using tetraprimer arms PCR, a low-cost technique capable of assessing multiple genes simultaneously. Let me introduce the technique. Tetraprimer arms PCR employs 4 primers for a single gene to detect mutations. When the primers bind to the mutation site, DNA synthesis begins. This process generates DNA fragments of different lengths, allowing easy differentiation between mutant and non-mutant ducks. This technique requires basic PCR equipment and components, thereby saving costs. Moreover, another set of tetraprimer arms PCR can be added to the reaction simultaneously to assess another gene. And similarly for more genes. After, all duck individuals have been identified as mutants or non-mutants. The data is transferred to a computer for statistical analysis and prediction of egg performance. The results will be sent to the breeder. The results will indicate which ducks should be eliminated and which ones should be retained for selective breeding. We'll isolate ducks predicted to have high and low productivity to monitor them separately. Ducks predicted to have high productivity will be retained to create subsequent generations, while those with lower productivity will be eliminated.